Section 2.4, scatter plot, correlation, and regression. There are three definitions here: correlation, linear correlation, and a scatter plot that we would like to discuss here. First, let's look at the very simple example of equation, straight equations. Let's say you have an equation in algebra is y equal x plus 1. Any first degree equation in algebra or is equation of a straight line, they call it also linear equations. So to graph this equation, we come up with some arbitrary points. We take some arbitrary numbers for x, we plug it into equation and find a y value. So you have 1, 2, 3, 4, 5 pairs of equations. So when you plot these points and you connect them, you have a straight line. So this is a strong correlations among all these points, or 100% correlations among all these points, because they all are on a straight line. So in that case, if I take a number, let's say x equal 4, and I want to find a y value for this x, and I don't have the equation, let's assume I don't have this equation and I have this graph, and I give you a point x equal 4 and I ask you to find a y value. Since you already have the graph, you find x equal 4 on the horizontal line, then you draw the vertical line and then horizontal line. The value of y is easily defined. Okay? Because you have a good correlations among all these points. So another example, let's say I have this graph. You don't know what the equations are, but we have all the points. All the points, if I draw a straight line, all the points are clustered or are very close to this straight line. So in that case, if I give you the value of x equals 7 and ask you to find the y value, all I need to do is find the x equals 7 on the horizontal axis, draw the vertical line and the horizontal line to find the y value, because you have a very good correlations among all these points. What if you have a graph like this? All the points are scattered, so I cannot draw a straight line that has all the points clustered around the straight line. So there is no good correlations here. In that case, when you have the value of x equal 3, you cannot find the y value because you cannot draw the straight line. All these points are scattered. Now, you can see on these pictures, you have a good correlations. So if I draw the straight line here, almost all the points are adjacent to this straight line, or this one is a good correlations. The only difference is this is a positive and this is a negative. Why this is a positive or a negative? If you recall a slope in algebra, slope going in this directions, climbing is positive, a slope, this is declining, or a slope is a negative. The same thing here. When you have all the points, they all are increasing, whether decreasing, then your slope is positive or negative. For correlation, we are using the letter of R. R show how strong the correlation or how big the correlation is. For instance, the maximum correlation is 100% or 1. So 0.85 is a good correlation, good positive correlations. Minus 0.9 is good negative correlations. But you could look at this example here, but in this example, then you see that we have all the numbers are scattered. So you don't have a good correlation. So R value is really, really small. or here is a curve, is not a straight line. So the reason we have a linear correlation means they must be on the straight line. Now, if the value of R always has to be between 100% and negative 100%, between 1 and negative 1. So if your value is between minus 0.8 and 0.8 is a moderate correlations. If it's between minus 0.5 and 0.5 is a very big correlations. And anything beyond minus 0.8 and 0.8 is a strong correlation. So value of R determine whether you have a good correlation or weak correlations. The value of R has been calculated using different methods. One method is using this formula. If you have all the X value and Y value when you want to calculate the R, you could use this formula. Or there is another formula that this formula is dealing with mean of X and standard deviation of the X. Or you could use the technology, which is easiest way to do. On these examples, there are some X value are given here. X values are 5, 6, 4, 4, 5, and Y value is 6, 9, 3, 2, 11. So these are your X and these are your Y value. So you take all this and plug into these equations. What is sum of X? Sum of X means you add all the X's. What is sum of Y? You add all the Y, X to power of 2, Y to power of 2. You need to have all this information to plug into this formula. Or if you want to use the second method, hand calculations, you have to calculate the mean for the Y, the standard deviation for Y, so on. But the best method is using the calculator. And you could see that on this example. On this example, we want to calculate the R. This is the better illustrate the calculation of R. We use table 10.2, which lists 5 of the pair value. So 5 X's and 5 Y's are given. These are the pairs. So all the X's are 5, 6, 4, 4, 5, and Y's are 6, 9, 3, 2, 11. So to do that, you could either draw the table, do the hand calculations. X to power of 2 means you take each number and raise it to power of 2. Y to power of 2, you take each number and raise it to power of 2. XY means you multiply these two, and then you find sum of all this. Remember, in this formula, we need sum of X, we need sum of Y, we need sum of XY, we need sum of X2, and we need sum of Y2. So when you find all these numbers, you input into this formula, and the R value is 0.795. Now you could use a technology or TI-84 and TI-83 calculator, and this is how to do it. So what you do is, if you want to use the calculator for it, stat edit. What you do is you input all the X's on this. 5, 6, 4, 4, 5, you enter all those numbers, and then you go to L2 and you input those numbers on the L2, okay? So now L1 and L2 has all the X and Y value. Input L1 and L2, then go to a stat and do the calculation and two variants. So go back to stat, go to calculations, and number two var stat, because you're dealing with two column of numbers. Then you enter. It shows that all the x's are in L1 and all the y in L2. Scroll down to calculations. So all these numbers that we calculate here, they all are here. You see that, like, you know how you have sum of x24, you have sum of x24. You know, you have sum of x2 is 118, sum of x2 is 118. You could take all the numbers from here, or if you want to use other method that require x1 and y1, you could use this. See, all the numbers are here. So by this method, you could actually calculate all these numbers and then take it and plug it into these equations. Or if you want to find the R, you go to stat, you go to test, and then this one, LINREGT test, it already have L1 and L2. And this one, it doesn't matter which one you pick, but then you go straight to the calculation. Calculator understand that you have all the information in L1 and L2. So you just go ahead and calculate. So here, it gives you the value of R is 0.795, which is what you have here. So that's how to calculate your R value using the calculator. Now, when you calculate the R, if the R that you calculated is greater than R from table A5, see table A5, this table, it tells you how many numbers do you have. For instance, on this example, on X, how many numbers do we have, or how many pairs? We have 1, 2, 3, 4, 5 pairs, right? We have 5 pairs. If you have 5, if your n value is 5 pairs, and we normally use this alpha 0.05, you should have at least 0.878. 0.878. So you have the correlation, but it's kind of moderate because yours is 0.795. So that's how we use the table A5 in order to decide whether there is a correlation or not. The calculator also gives you the p-value. You compare that p-value with the alpha is that 0.05 that you have on table A5. On this table A5, these are your alpha value. This is another example. It's not in the homework. This is examples that you have list of 2, L1 and L2, and you want to draw the scatter plot, which I'll show you on the next examples. And then you calculate the R from using the calculator. And if R of calculator is greater than alpha, which is 0.811, so here, if you have 6 pairs, you have to have 0.878. So the alpha I calculated is 0.841, is greater than 0.811. So there is a good correlation. See, a statistician came up with this table that they're saying depend how many pairs of data do you have. Based on that, the minimum is this numbers. Like if you have 6 pair of data, like here, 1, 2, 3, 4, 5, 6. If you have 6 pair of numbers with alpha of 0.05, which in this problem is given to you anyway, then you should have 0.811. The boundary is 0.811. And I'll show it here. So yours is 0.841, is greater than that. That means you have a good correlation. Now the homework assignment. The first 2 problems are multiple choice questions. They said choose the correct answer below. A is correct. Why? Because the linear term of linear refer to the straight line. The error measure how well a scatter plot fit the straight line. And on this one, what is a scatter plot? A scatter plot is a formula that fits a straight line to data point. Now, there are instruction of how to graph a scatter plot using the calculator. And there are 3 problems here that you need to input these numbers into your calculator. So what I did, since these problems are very similar, I tried to do this one. So what I did was I tried to take all these numbers and input that into my L1, and then the other one into L2, and then draw the scatter plot, okay? So for that, again, you go to edit, first stat, the first one is edit, you enter. So what I do is I already put the numbers. You see all these numbers are 25, 95, and 290. I put all these on L1 and these are L2. You enter all this. And then you have what? 1, 2, 3, 4, 5, 6, 7 pair. When you finish that, now you want to use a scatter plot. Scatter plot, go and find test. Stat. Test. This is how to calculate the R value. But if you want to graph it, so this is when you want to find the R value, right? Now, you want to do a scatter plot. You want to plot all these points because you already have an L1 and L2. So you go to a stat plots. The stat plots is this one here, is the blue line. So you go second that. You want to make sure that the first one is on, means when you enter, if this is off, then you got to turn it on. You got to move it to the left and click that. And then you pick the first one. The first graph is a scatter one. And calculator already know that your information is in L1 and L2. So everything is fine here. So a stat plot, then enter. Make sure the first one is on. And select the first chart, Now, go to zoom, and number 9 is zoom stat. Zoom is this one. Go to number 9, zoom stat. That gives you the scatter plot. And then on these problems, you see that the correct one is this, based on that information. Okay, so that's how you could use your calculator to answer questions here. And on the last problems here, they are giving you the R value. They are saying there are 6 numbers, 6 pairs, and R is 0.168. They want to know if this 0.168 is a good correlation or not. Since there are 6 pairs, it has to be minimum 0.811, means your correlation must be beyond 0.811 or below minus 0.811. Your correlation is very close to the 0. So basically it means it's not a good correlation. So correlation coefficient 0.168 that is given in the problems is not a good correlation. So there is no sufficient evidence to support the claim of linear correlations. So to have a good correlations, you have to have at least 0.811 if there are 6 pair of numbers. And the last page is solution or answer to those problems.